attending and allowing me to present to you what I've been working on. I've been working on a genetically programmed environmental sampling processor for remote ocean mixotroph detection. So as you know, plankton plays a big role in our ecosystem. They help larval fish. They help the growth of larval fish at critical stages of their lives, but they can also kill whole ecosystems in a matter of seconds. Plankton are dinoflagellates, and dinoflagellates are a mixotrophic protist. Mixotrophs are basically mixotrophic organisms combined with eating features of animals and plants. Simply put, they can eat and hunt prey, but if prey is scarce, they can make their own food via photosynthesis. Mixotrophs are dangerous because in the presence of nitrates and organic nutrients brought upon by sewage runoffs into the oceans, they produce an abundance of toxins and mucus. The toxins kill the fish, and the mucus the muddy colored foam seen in estuaries during summer is the result of the plankton secreting excess mucus, which can clog the gills of the fish, thus drowning them. An example of a harmful algal bloom is called red tides, as you can see here, and this is one of the closest ones that the closest ones to us in San Diego. And red tides are caused by dinoflagellates and diatoms, a major group of algae. These algal microorganisms release toxins into the ocean, such as diatoms release amino acids and dinoflagellates release gasotoxins. These toxins lead to the detection of HABs. The fecal indicator bacteria, FIV, were discovered through basic microbiology media assays such as PCR. PCR stands for polymerase chain reaction, and it's a technique used in molecular biology by amplifying and analyzing a piece of DNA for identification of a species, a person, or an organism. The ESP design proposal addresses the need to monitor HABs and FIVs in real time in the ocean with two types of ESPs. A mobile ESP such as a NOAA Ocean Explorer, I don't know if you're familiar with that, and a few station ESPs such as the NextSense buoy. The ESP will perform basic onboard immediate detection using a PCR protocol developed in the lab over the past 5 years, the AGS-16S assay, which I will explain further. And this can be miniaturized in a film array type format. Additionally, the ESP will return samples for next generation sequencing analysis. In 2012, my lab and I started studying the relationship between HABs and FIVs and how they support each other. We decided to collect water samples from various locations along the Ventura coastline, where we are situated, and found two algae organisms, the Pseudo-nitzhia and the L-polyedra, that have been releasing harmful toxins and were constantly present at every location tested. Bacteria were found in the sample alongside the algae, which led to tests that ran in 2013 to see which bacterial species were associated with the HABs. This isolation protocol, we use the national standard for filtering ocean water samples, and this isolation protocol of algal and bacterial species can be miniaturized in the ESP. And in our lab, the classic SPC-16S assay, which took about 5 days, if not 6 days, was initially used for discovery of the antibiotic-resistant Vibrio paraphimolyticus. This is the method that the government uses in order to detect harmful ocean microorganisms. A more refined assay was developed in my lab, and it's called the AGS-16S assay, and to detect Vibrio paraphimolyticus, and it worked pretty well, and it only took 2 days, which is more time efficient than the national standard. This assay can be miniaturized in the ESP. This is the proof of principle. The SPC-16S assay and the AGS-16S results demonstrate equivalence for the rapid isolation of antibiotic-resistant Vibrio using AGS-16S in our lab versus the national standard for filter analysis. Since 2015, I have been running the rest of the filters for PCR testing to send on to microbiome analysis. Currently, this semester, I am using the samples retrieved from the ESP for next generation analysis via the land-based ocean bacteria DNA isolation protocol, which can be shortened to 16S, 18S, LB, NGS assay, which is the short version of saying that. This is an overview of the 16S, 18S land-based next-generation sequencing assay for microbiome analysis with bridge application. This process takes weeks, so it's very time-consuming. However, it's highly accurate. We use this method when we want to further study a site that the ESP has tested and showed high activity in that site. This detects all bacteria, FIVs, and all algae HABs, but must be land-based. The ESP sample retrieval is necessary for this analysis. And back to the proposed CSP design, as you can see, this is a film array pouch. A film array pouch is a proven technology that can detect 30 DNA targets using the PCR technology within 1 hour in a genetically programmed self-contained pouch. I intend to program detection reagents for the HABs, FIVs, and antibiotic resistance in this program. This technology is intended to be on board the ESP for multiple real-time analysis. This pouch will perform the AGS-16S assay that was mentioned in my lab. The familiar reagents pouch contains all the required reagents for the sample preparation. A 0.22 micron meter filter will be incorporated into the onboard filtration device, which is this one. And this onboard filtration filter device miniaturizes the land-based filtration method used by our lab and also by the national standard government. Once the sample is collected and filtered, it will go through these steps and also the list of the organisms that we have collected in the past few years will be inserted into the reagent storage. So each device will include 2 modules, an auto-sampler PCR film array bag, and a filtration device with a 0.22 micrometer filter. And also it would also include a water sampler. I propose to have 1 mobile ESP per 5 station ESPs at each location. The mobile one will take samples from different areas of the location to test for high activity onto where you can place the buoy type ESPs. And the station ESP, the buoy one, is for more refined testing. The NOAA Ocean Explorer based ESP will include 10 pouches per unit, and it will be kind of like a rover type, so you can control it from a remote area, and you don't have to be at the location. And so we want the mobile one to circulate the area to tell us where the best places to drop the buoys at. And you can retrieve the data from the PCR via USB. And also, the buoy type of ESP is going to be solar powered, and you can collect the data via Wi-Fi. And also, each unit will include 7 pouches, 1 test a day for a whole entire week. The melting point curve results from AGS-16S assay are expected to be similar to the data from the onboard film array bag on the ESP. Each HAB, FIV, and antibiotic resistance gene PCR has a unique melting point in the analysis, so you can easily detect which one's which, and it's like having like your own personal thumbprint, I guess. This is suggesting a standard, and because state assays are not up to date. As you can see, the state government takes 5 days to perform PCR, whereas our method takes 2 days. So we need to have a network of these kinds of devices for recreation and food production. And our device will test at multiple sites. Testing done in our lab, the testing that has been done in our lab proved that there are these critters at every site we have sampled and tested, but the testing PCR method took more than a week or 2 to perform just to find these critters, whereas this device will save us so much time because results can be acquired within minutes or even an hour. So it's, as you can tell, it's highly time efficient. Therefore, more sites can be sampled, and it's local and automated. And it's less costly because, I don't know if you know this, but PCR data analysis costs about like $2,400 per 1 group of million DNA bases. And that is how the state is conducting this kind of testing today. These devices save money because you don't need to send off samples for PCR analysis, and PCR technology is already integrated into the system. Oh, sorry. Okay. So as I've explained, plankton can be altered into doing harm in our marine ecosystem. Determining the origin of HAB and FIVs remains obscure. However, some causes can be rising ocean temperatures and the correlation between seasonal temperature and water contamination. Other factors include agricultural runoff, outdated sewer systems, improper waste treatment, and antibiotic resistance in fish hatcheries. HAB toxins and FIVs also affect fishing industries, tourism, public health, and ocean ecosystems wherein the toxins kill the fish by poisoning them, and also seizures can occur in marine animals as the toxins move up the food chain. National security is also compromised because toxins in the water affect the water used in Navy ships' basic functions. Contamination of fishing hatcheries can cause pathogenic illnesses in humans, such as amnesic shellfish poisoning, paralytic shellfish poisoning, diarrheal shellfish poisoning, a neurotoxic shellfish poisoning, and also possibly human mortality. Integrated land-based microbiology, PCR, and next-generation sequencing microbiome analysis, combined with remote specifically focused on ocean-based ESP devices, are proposed to improve regular ocean monitoring. Using these two methods together provide not only reliable data to agencies responsible for the safety of coastal waters and food supply, but it also allows for more informed decisions. If we have this device, we can speed up the process. We don't need to bring samples back into the lab to do PCR testing when the device already does it for you and provides you data instantly. And so we can jump immediately to microbiome testing for further study. The ESP mobile device is suggested to be waterproof and withstand highly salinized and highly pressured environments in the ocean. And I don't know if you've heard this, but NASA is planning to drill toward Europa's ocean in search for life. And Europa, I don't know if you know this as well, but it's the moon and it's one of Jupiter's moons. So if we bring our device in Europa's oceans, imagine the organisms that we can find. Thank you for listening, and if you have any questions, feel free to ask.
Thank you very much. Any questions from the audience? Judges?
Yes. You're proposing this